Let's look at question 21. The diagram shows 4 identical spheres placed between 2 wooden blocks on a ruler. What is the diameter of one sphere? Well, here we actually have 4 spheres, and I hope you can see that it starts from 4 centimeters and finishes at 12 centimeters. Now the wooden blocks are very helpful here, especially in the likes of paper 6, because when you touch a wooden block, a flat edge wooden block with a sphere, you know that it's touching the outermost part of the sphere. In other words, it lets you find the diameter a little bit more accurately. So the difference between 4 and 12, I hope you can see, is 8. And there's 4 of them, so 8 divided by 4 is 2. The answer, B for ball. Question number 22. The diagram shows an unbalanced rod. 2 loads X and Y can be moved along the rod. The rod turns in a clockwise direction as shown. Which action could make the rod balance? So if it's turning in a clockwise direction, quite clearly the clockwise moment is bigger than the anti-clockwise moment. So what you're trying to do is make the anti-clockwise moment bigger. So which one of these actions will make the anti-clockwise moment bigger? Well, I hope you can see the answer has to be A. Because if you move it to the right, X is getting closer to the pivot in part B there. Therefore, it would be a smaller moment. Moving Y to the right makes the clockwise moment even bigger, and moving the pivot to the left would again make the anti-clockwise moment smaller. You're trying to make the anti-clockwise moment bigger, that's why it's A. 23. A car travels along a straight road. The speed time graph for this journey is shown. During which labelled part of the journey is the resultant force on the car 0? Well, that's Newton's first law. It's when the car is travelling at a constant speed. I hope you can see that's at B, because the resultant force must be 0, because Newton's first law says an object will either remain at rest or move at a constant speed in a straight line unless acted on by an unbalanced force. Question 24. The mass of an object is measured on Earth. The mass is 5 kilograms. The object is taken to the moon. The mass of the object is measured on the moon. What is the mass of the object on the moon? Well, we should know that the mass does not change, so it's going to be exactly the same. 5 kilograms, the answer is C. Only weight changes, mass will not. Question 25. In a factory, 2 men X and Y try to move identical heavy boxes P and Q. Man X tries to push one box P along the floor. The box does not move because an object is in the way. Man Y lifts box Q from the floor onto a shelf. Which man does the most work on the box, and which box gains the most energy? When we do this, very often we put ourselves in the situation where here the question is asking what's actually been done to the box. So some students might think that if you've got an object in the way of box P and you're pushing it, they'll think that they're doing a lot of work because they can't actually move it. And again, they're bringing themselves into the equation, whereas we're only focused on the actual box itself. So if you look at the man X pushing box P, well, he's not doing any work to the box because the box not actually moving. Whereas man Y is lifting box Q, basically he is definitely lifting the box, so he's doing work on Q. So what's the answer here for 25? I hope you can see the answer must be D. Why? Because Q is actually moving. It's got a distance. It's got a weight, so you're actually doing work on the box. And therefore, man Y is actually doing the most work himself because the box is also gaining the most energy. Whereas man X pushes box P, it's not going anywhere because it's not actually moving any distance whatsoever. Question 26. The diagram shows a steel spring and a graph of its length against load, not extension. What is the extension of the spring when a load of 20 newtons is applied to it? Well, guys, here, when the load is 0, the length is 5. Okay? There's no extension at this point. When there's a 20 Newton load, the length becomes 8, but extension is new length minus the original length. So 8 minus 5 here, when there's no weight, is 3 centimeters. So the answer is A. Question 27. A cook wants to prepare some food to be cooked by 1:15 p.m. He uses an oven with an automatic timer that can be set to switch on and off at a certain time. The oven needs to be switched on for 2 hours and 10 minutes. At which time does the oven need to be switched on? Well, it needs to be cooked by 1:15. So quite clearly the time cannot be after 1:15, it needs to be before 1:15 because it needs to be finished at 1:15. Then it's a matter of being able to convert 2 hours and 10 minutes to suit this time of 1:15. Well, the answer's A because 2 hours after 11 is 1 o'clock and a further 10 minutes will make it 1:10. But we didn't actually start from 11 o'clock, we started from 11:05. So if you add 2 hours and 10 minutes, it becomes 1:15 p.m. The answer is A. Question number 28. Which statement about mass or weight is correct? Well, I hope you can see that it's D, that weight is measured. Sorry, my apologies. I hope you can see that it's C, weight is a force. D is incorrect because weight is not measured in kilograms, weight is measured in newtons. B is not correct because mass is measured in kilograms, not newtons. And A is not correct because mass isn't a force. Mass is the amount of matter in an object. So the answer is C, weight is a force. Question 29. A metal block has the dimensions shown here. Its mass is 1000 grams. How do you find the density of the metal? Density is mass divided by volume. You've got to calculate the volume here of 10 times 5 times 2. So what is giving us mass divided by volume? I hope you can see the answer is D. 1000 is the mass divided by, in this case, they've said it differently, but ultimately it's the same thing. 2 times 5 times 10 is the volume. 29 is D. Question 30. A ball is dropped from a tabletop. Air resistance may be ignored. Which row describes the velocity and the acceleration of the ball at point X? Well, if air resistance is ignored, the velocity is going to increase. It's going to get bigger and bigger and bigger because the acceleration due to gravity is the same. It's 10 meters per second squared, or gravitational field strength is known as 10 newtons per kilogram. I hope you can see, therefore, the answer must be B. The acceleration due to gravity is the same, it's 10, but the ball will keep speeding up, or its velocity will keep increasing by 10 meters per second every second.